Alrighty, Pythagorean Theorem. You probably learned this in 8th grade, so this should go pretty quick. I always say that. This will be so fast because it's always fast. Ha ha ha. Okay, so the longest side of the triangle is opposite the right angle. And that side is called the hypotenuse. Hypotenuse. All right. Pythagorean theorem is only for right triangles. Other triangles have the sides that you can find, but you can't use Pythagorean theorem. Only right triangles need apply. All the rest, out of luck, or you're out of luck. Okay, so I did not mean to do that. So the Pythagorean theorem is that in a right triangle only, the sum of the square of the two legs, here's my leg, and here's my leg, and what's this one called? The hypotenuse. Okay, so I should be able to square a leg and add them together, and I should get the square of the hypotenuse. So we're always going to have A and B be the legs, C is always going to be the hypotenuse for these examples. So, for example, if I drew a triangle, okay, here's my hypotenuse. So if A is equal to 8 and B is equal to 15, then I should be able to write 8 squared plus 15 squared equals C squared. So 8 squared is 64, and 115 squared is 225. And if I add those together, I get 289. Now I have to take the square root of everything. C equals the square root of 289, which happens to be C equals 17. So 8 squared plus 15 squared equals 17 squared. So my hypotenuse is 17. Okay, for my next example, I'm not going to draw the picture, but you should know those are my two sides, and I'm looking for my hypotenuse. So 6 squared plus 8 squared equals C squared. So I have 36 plus 64 equals C squared. 100 equals C squared. Take the square root. C is equal to 10. Straightforward, easy. Use your calculator, and you can find these no problem. Until you get to example 3, and you go, what? Okay, now I have the hypotenuse in one side, and I'm looking for the other side. If A squared plus B squared equals C squared, then C squared minus A squared should equal B squared. So I'm going to put 100 minus 25 equals B squared. B squared equals 75, and I need to take the square root of everything, so B equals the square root of 75, which is not a perfect square. B is equal to the square root of 3 times 25. This is a perfect square, so I'm going to end up with B equals 5 times the square root of 3. So now we're using our simplifying radicals and Pythagorean theorem. So let's do number 4. I'm looking for C, so I'm adding my two sides. So I have 7 squared plus 9 squared equals C squared. 7 squared plus 9 squared equals 130, because I have 49 plus 81 equals C squared. C squared equals 130. Take the square root of everything. C equals the square root of 130. 130 is, I'm going to do it up here. 130 is 5 times 26. 26 is 13 times 2. None of those have matches or are perfect squares. So this is as simplified as I can get, and C equals the square root of 130 is my answer. but I did double check just to make sure that there wasn't a perfect square hiding in there somewhere. Okay, number 5. So I'm looking for a diagonal of a rectangle. So here's my rectangle, here's my diagonal, there's my right angle, here's my side, and my hypotenuse. So I have a length of 6 and a width of 4, and I'm looking for my C. So I have 4 squared plus 6 squared equals C squared. 16 plus 36 equals C squared. C squared equals 52. Square root everything. C equals the square root of 52. 52 is 4 times 13. So I end up with a perfect square. And so C is equal to 2 times the square root of 13. Okay, number 6. Find the other side. So I know I'm going to subtract because I'm looking for the other side. If you want to draw the picture, I'm always loving drawing the picture. I have a 10 and an 8 and A or B, it doesn't matter, which is the one I'm missing. So I'm subtracting 10 squared minus 8 squared equals A squared. 100 minus 64 equals A squared. 36 equals A squared. Square root everything. A equals 6. Sometimes they're perfect squares and sometimes they're not. Okay, and then I kind of messed this part up down here. I'm talking about these special right triangles, which are not these ones down here. So I'm going to talk about that in a second. So let's go ahead and solve for x. And I'll talk about 2 different special cases for right triangles. If I'm looking for x, I am obviously squaring my sides. So I have 2 squared plus 4 squared equals x squared. X squared equals 4 plus 16, which is 20. I'm going to take the square root and I get x equals the square root of 20, which is on our paper. X equals 2 square root 5. This one over here I'm going to subtract. So I have 11 squared minus 9 squared equals x. 121 minus 81 equals x squared. X squared equals 40. X equals square root of 40, which is 4 times 10. 4 is a perfect square. So x equals 2 times the square root of 10. Okay, this last one over here is an isosceles triangle. Okay, so if I have 90 degrees here and 45 here, this other angle has to be 45 because I have to have 180. So 45 and 45 is 90. The other angle is a 90. So there's my 180. So that means this other side is also 3 because if my angles are the same, the sides have to be the same also. So I'm looking for x, and I have 3 squared plus 3 squared equals x squared. 9 plus 9 equals x squared. X squared equals 18. X equals square root 18. X equals 3 square root 2. Isosceles triangles are special triangles, and I'll start with an easier one, and you can hopefully see the pattern. Okay, if I have a triangle that's a 1, and I'm looking for this side, then I have C equals 1 squared plus 1 squared. C squared equals 2. C equals square root 2. Okay, so if I have a 1 and a 1, I end up with square root 2. If I have a 2 and a 2, I end up with 2 square root 2, and you can figure it out and make sure. And then the one above, if I have a 3 and a 3, I end up with 3 square root 2. So this right here is kind of your secret for isosceles triangles, when the two sides are the same length, the hypotenuse is the same number as the length times the square root of 2. So if I have a triangle that's 4 and 4, hypotenuse is 4 times the square root of 2. So that's one special triangle. The other one is the triples, triplets, triples. And you saw some of those already up on the paper. Anything that comes out with 3 whole numbers and not a radical sign is one of the triples. So if you look back on your paper, 6, 8, and 10 is a triplet. 3, 4, and 5 is a triple. See if there was another one. There was one with 17. 8, 15, and 17 is a triple. 8, 17, and 15 goes down here really small. Okay, so there's also triples, which we're going to talk about Friday, Monday, because we're back up behind today, and how you can find them, because just like I was saying, it's nice to know square root of 20 is 2 times the square root of 5 without doing much work. It's nice to know if you see a 3 and a 4 that you already know the hypotenuse and you don't have to do a lot of work to find it. So there is your Pythagorean theorem and how it works, and I'll see you Friday.